Now we're going to take a look at JT6m's filter system. Please press erase, reset the decoder to its default settings if you've not done so already, and load in the AC5TM WAV file. In so doing, you will see that the graphical area shows a number of undulating points on the yellow lines, suggesting that a number of synchronization tones have been detected, but no automatic decode. Focusing now on the filter system, this is implemented by the use of the TOL box and its adjacent freeze checkbox. TOL or tolerance, is used to confine WSJT's search to a particular bandwidth. When freeze is unchecked, WSJT is not confined and will search approximately ± 600 Hz for any useful data. By checking the freeze box, you immediately confine WSJT's search to a specific bandwidth as specified in the TOL box. So in this instance, it would be 200 Hz. Without making any other changes, now press the decode button and immediately the graphical area changes and a proud synchronization tone appears in the display. And also an automatic decode has also occurred showing K1 SIX. Now please open the next WAV file in the series, which is AF40. To ensure that this message is not contaminated with previous decode efforts, press the erase button and force a decode again. Now in the AF40 file we see that the yellow line is principally flat, but there is a very proud synchronization tone shown at approximately 25 seconds. If we look at the decodes, you will see that there is an automatic decode at time t 4.7 seconds, which shows a call sign which we have become familiar with over the previous exercises. And further down we see at 24.2 seconds AF40 K1 JT. Focusing momentarily back at the graphical area, if we actually take our cursor to 4.7 seconds, we will see that there is some enhancement over the normal spectral analysis. If indeed we click somewhere within this area, you will see substantial decodes appearing as a result of random clicking within this enhanced area. Staying on topic, there is another important aspect of the mode which we need to consider, and that is the response of WSJT's filters. We know that checking the freeze box locks WSJT into a narrower filter response, and that filter response can be adjusted by the mouse button from a value ranging from 400 right down to 10 Hz, which is a very narrow response indeed. We can now demonstrate how important this particular element is, because the sharpness of WSJT's filter could easily prove to be a hurdle. If you recall, we mentioned in a previous section the purpose of the DF column. This is an integer which represents the difference in frequency that the origin signal has when compared with your own system, and can be a positive or a negative figure, and the value is in Hertz. Using this WAV file as an example, we can see that the decodes between 8 and 10 seconds have a difference in frequency of 7 Hz, meaning that the origin transmission is 7 Hz higher than our receiver. So if this were a real transmission, we would be able to turn our RIT up 7 Hz, and the following decode would then read a DF of 0, meaning that our receiver would then be on the same frequency as the origin signal. If now we adjust the value in the toll box down to a much lower value and then click and force a decode between 8 and 10 seconds, it will still result in a clear and good decode appearing in the decode box. And indeed, we could adjust the value of TOL right down to 10 Hz. Because the DF displayed is ranging from 5 to 7 Hz in the display, it is still within the filter boundary. Now I will demonstrate just how sharp the filters are with WSJT, and thus demonstrate how critical the filter setting can be when you're in a QSO. Please adjust the TOL to 100. Ensure the freeze checkbox is checked. This limits WSJT to searching a plus and minus 100 Hz of its center frequency. A lesser known feature of WSJT, in JT6m specifically, just below the clock you will see there is a box entitled Freeze DF, and this value is indeed closely tied up with the TOL and the freeze box. The value of Freeze DF can be adjusted using the F11 and F12 keys on your keyboard, and again can range as positive and negative integers, and they increment in values of 5. This feature can duplicate the effect of adjusting your radio's RIT in a positive or negative value. So for example, if the value in the DF column were a positive value of 100, you could have the option of either increasing your radio's RIT by 100 Hz, or alternatively, you could leave your receiver's RIT alone and you could increase the freeze DF value by 100, thus simulating the increase in RIT. I will explain the benefit and function of adjusting the freeze DF value at the end of this next exercise. With TOL set at 100 and freeze checked, it means the WSJT has a tolerance of plus minus 100 Hz of your receiver's center frequency. Using our AF40 WAV file as the example, this means that the incoming signal with a DF of 7 is 7 Hz higher than our receiver frequency. Therefore, it would be fair to say that if we were to lower our RIT by 90 Hz, with the incoming signal already 7 Hz higher than us, and with us going down in frequency, this would actually mean a net difference of 97 Hz. By the use of the F11 key, adjust now the freeze DF value to minus 90. This simulates us adjusting our RIT minus 90 Hz. Click anywhere within the 8 to 10 second arena and you'll see that WSJT happily continues decoding the signals. Pressing F11 one more time, simulate reducing your RIT by a further 5 Hz and adjust freeze DF to minus 95. Click in the same area again and you will see that WSJT will no longer decode anything that appears in the spectrum. Now, to compensate for this, we could increase the bandwidth that WSJT is looking to. So adjust TOL to 200 and click in 8 to 10 seconds and we have ourselves decodes again, because we have widened WSJT's filter. Narrow TOL back to 100 and try decoding, and again WSJT is not interested. I now leave you with a short list of reminders and hints for the art of decoding.